More than 4.5 billion years ago, Earth already existed, but there was no moon in the sky. The young solar system was still under construction, filled with dust, rock, and growing planetary bodies moving through unstable orbits. Planet formation was violent. Small worlds repeatedly collided, merged, shattered, and changed direction. The planets we know today are survivors of that chaotic era, not objects that formed quietly in perfect circular paths. Young Earth was hotter than it is now. Its surface was repeatedly melted by impacts, radioactive heat, and compression. It may have rotated much faster, with a day lasting only several hours. One large protoplanet, often called Theia, moved onto a crossing path with Earth. It may have been roughly the size of Mars, although its exact mass, speed, and angle remain uncertain. Theia struck Earth in an enormous collision. The impact released extraordinary energy. Melting and vaporizing rock material from both bodies was thrown into orbit while the surviving Earth became even hotter. The debris did not instantly become the moon. For a time, Earth was surrounded by a disk of molten and vaporized rock. Collisions inside that disk changed the sizes and paths of countless fragments. Gravity gradually pulled much of the orbiting material together. Within a geologically short time, perhaps years to centuries, a large body formed. This was the beginning of the moon. The newborn moon was extremely hot. Much of its outer portion may have been covered by a deep magma ocean, where heavy and light minerals separated as the world slowly cooled. Light minerals, especially plagioclase, floated toward the surface and helped form the moon's early crust. This bright ancient crust is still visible across much of the lunar highlands. The moon began much closer to Earth than it is today. Strong tidal interactions transferred energy and pushed the moon outward, while Earth and moon became locked into a changing gravitational partnership. As the moon moved away, Earth's rotation slowed. A day that may once have lasted only a few hours gradually lengthened. The process continues today, though extremely slowly. The early moon was struck by many asteroids and leftover planetesimals. Giant impacts created enormous basins, while smaller collisions produced the dense pattern of craters still preserved on the airless surface. Later, molten rock rose from the moon's interior and flooded some of the largest impact basins. These dark plains are called maria, an old word meaning seas, even though they contain no liquid water. The near side and far side look surprisingly different. The near side has more large dark maria, while the far side has thicker crust and fewer broad lava plains. Scientists are still studying why. The moon influences Earth's orientation. Its gravity helps limit large changes in Earth's axial tilt, which may have contributed to a more stable long term climate than Earth would otherwise experience. Tides are another visible result of the Earth Moon system. The moon's gravity raises ocean bulges, and Earth's rotation carries those bulges forward, transferring energy and slowly pushing the moon farther away. During a solar eclipse, the moon passes between Earth and the sun. By coincidence, its apparent size can closely match the sun's, producing one of the most dramatic sights in the sky. For most of history, people could only study the moon from Earth. That changed when Apollo astronauts collected rocks, soil, and core samples and brought them back for laboratory analysis. Lunar samples revealed ancient ages, impact histories, volcanic rocks, and chemical similarities between Earth and Moon. Those similarities strongly support a shared origin through a giant collision. The giant impact model is the leading explanation, but the details are not finished. Scientists test different impact angles, speeds, spinning Earth models, and multiple impact possibilities using computers and laboratory measurements. The moon is not completely inactive. It experiences mooncakes, preserves ice in permanently shadowed polar craters, and records billions of years of solar system history with almost no erosion. The moon formed through catastrophe, but it became Earth's long term companion. Its rocks preserve the violence of planet formation, while its gravity still changes our oceans, rotation, and view of the sky.